Greetings there, Mr. Sutton here, bringing you the Pre-Cal Honors 7-3 Part 2 homework solutions on parametric equations. On this problem, we're trying to write these parametric equations in a rectangular form and identify the shape. So I'm going to start, since I have trig functions, I'm going to start by isolating the trig functions and squaring both sides. So over here we can write cosecant equals x over 2. And the reason I'm doing this is I'm eventually going to plug these into Pythagorean identities. So now I can write this as cosecant squared of t equals x squared over 4. Again, just squaring both sides. Next, this is already isolated, so I'm just going to square both sides over here and get cotan squared of t equals y squared. Next, I need an identity that incorporates cosecant and cotan squared. I know that 1 plus cotan squared is cosecant squared. So cosecant squared minus cotan squared of t is going to be 1. Using this identity, I'm just going to substitute for these squared trig functions. So I can now write x squared over 4 instead of cosecant squared minus, well, we saw that cotan squared is really just y squared in this problem. And that is our rectangular form of these parametric equations. Now, identifying the shape, we have two squared variables with subtraction. So that's going to be a hyperbola. To put this next set of parametric equations in rectangular form, I'm going to isolate and square these trig functions. So I've got x minus 1 divided by 3, that equals sine of t. Squaring both sides, I have sine squared equals x minus 1 quantity squared over 9. Now I'm going to do the same thing for cosine over here. So I've got y plus 1 divided by 5 equals cosine. And then squaring both sides, I've got cosine squared equals y plus 1 quantity squared over 25, 5 squared. Next, I know by my Pythagorean identities that sine squared plus cosine squared equals 1. So I'm just going to substitute for those squared trig functions with what I got for my x's and y's here. So I can write x minus 1 squared over 9 plus y plus 1 squared over 25 equals 1. And now, in terms of identifying this shape, since I have two squared variables with plus between them, that must be an ellipse, especially since these denominators are not the same. If they were, it would be a circle. They're not, so it's an ellipse. To put these parametric equations in rectangular form, since I have trig functions, I'm going to isolate them and square them and then plug it into a Pythagorean identity. So let's take that one step at a time. Let's start with the x equation here. Dividing by 5, I have cosine of t equals x over 5. And now squaring both sides, cosine squared of t equals x squared over 25. Over here, I've got sine of t equals y over 5. Squaring both sides, that's sine squared equals y squared over 25. And I know that cosine squared plus sine squared equals 1. Substituting into that identity, I have x squared over 25. And for sine squared, I have y squared over 25. All of that equals 1. And if I really wanted to, I could multiply by 25 and make it look like this. It doesn't really matter which way you write it. Either way, you're in rectangular form. But maybe if you put it in this form, it's a little more obvious that this is the equation of a circle because we have two squared variables. They're being added. And we notice that the coefficients on them are the same, or the denominators here are the same. So that is a circle. On this problem, we're trying to write this set of parametric equations in rectangular form. Now, since I don't see any trig functions, since I just see x's, y's, and t's, I can just use direct substitution. I notice that x and t are the same thing, so I'm going to replace all the t's in this y equation with x's, like so. Now I am instantly in rectangular form, and this type of conic section, since I only have one squared variable, the x here, that's going to be a parabola. For number 10, to write these parametrics in rectangular form, since we have trig functions, let's isolate the trig functions and square them. So on the left side, we have x minus 2 over 5 equals cosine t. So cosine squared equals x minus 2 squared over 25. Over here, we have y plus 1 over 5 equals sine of t. So sine squared then equals y plus 1 over 25. And y plus 1 squared over 25. We know cosine squared plus sine squared equals 1. So then x minus 2 squared over 25 plus y plus 1 squared over 25 equals 1. And since these are both the same denominator, we can multiply everything by 25 if we want. This makes it clear that we are dealing with a circle, since we have two squared functions that are being added, and the a and the b are exactly the same, or the denominators are exactly the same. So circle it is. For number 12, we're trying to put this in rectangular form. So since we don't have any trig functions, we're just going to do some normal substitution to get rid of the t's. We see that x equals t, so then we can rewrite the second one as y equals negative x squared over 4. And this is definitely the equation of a parabola, one squared term. For number 7 and onwards, we want to write the parametric equations in rectangular form and then identify the shape. So let's start by getting these sine and cosine functions by themselves, because we're going to square them in a minute. So we've got sine of t equals x over 3, and then squaring that, we have sine squared equals x squared over 9. Over here, we've got cosine of t equals y over 2. So squaring that, we have cosine squared of t equals y squared over 4. Now, the reason we're squaring these is we're going to plug them into this trig identity right here. Sine squared plus cosine squared equals 1. So we can rewrite this as x squared over 9 plus y squared over 4 equals 1. Taking a look at what we've got, we have positive squared terms, and the denominators are different a and b value in general. So this means we're going to have an ellipse. For number 8, we want to write these parametrics in rectangular form and identify the shape. Let's isolate the trig functions in each of these equations. So we've got tan of t equals x plus 2 over 3. And then if I square that, I have tan squared equals x plus 2 squared over 9. Over here, I'll add the 2 and divide by 2. So secant equals y plus 2 over 2. So then secant squared equals y plus 2 squared over 4. Now we have the trig equation, the trig identity 1 plus tan squared equals secant squared. We can rewrite that as secant squared minus tan squared equals 1. And then if we plug these two things in for tan and secant, we've got, for secant, y plus 2 squared over 4 minus, and then for tan we have x plus 2 squared over 9. Since we have a negative squared term, this is going to end up being a hyperbola. To write these parametrics in number 9 in rectangular form, you'll notice that we don't have any trig functions, so we can just use normal algebraic substitution. We see here that t equals y, so we can just rewrite this as x equals negative y squared over 5. And if we have a single squared function in here, a single squared variable, that means we have a parabola.